Hi, welcome back to the course Foundations for Machine Learning. This is the start of a new module where we will be covering programming fundamentals required for machine learning engineers. So this lecture is a fresh start to Python. So if you are already familiar with the basics of Python, you can totally skip this lecture. I don't think this lecture is necessary for you if you are not a beginner. If you are a complete beginner, if you don't have that much background using or running programs or writing code in Python, then this lecture is for you. So let us get into the lecture. We will be starting with very basics of data types, and then we'll proceed to write a bit more complex functions towards the end of the lecture. So firstly, Python is a programming language. It is very much interpretable in the way it is written. The syntax is very easy to learn. It is by far the most popular programming language for machine learning. It is also used extensively in web development, and it's very easy to learn Python relative to many other programming languages. Personally, for me, Python was easier to learn than C or C++. And if you want to become a serious machine learning engineer, of course, you should know Python in and out. The other thing is there are a lot of libraries in Python that are extremely popular. The community support is very good. And also, since a lot of internet database is based in Python, large language models like ChatGPT or Cloud by Anthropic, all of these are very good at giving you solutions when you encounter problems in Python. So this is a chart which shows the from 2019 February and till 2020 February, in the searching of tutorials, which languages were the most prominent. Python was topmost, Java, JavaScript, etc. were next. Because in web development, Java is also used extensively, right? So that's why you see this kind of a trend. But it's very clear that Python is the most sought after programming language in the world. And these are some libraries in Python that are very popular with respect to machine learning, data science, deep learning, etc. Some of these are meant for data visualization like Seaborn. Some of them are meant for data analysis and implementing ML models. Some of them are for storing data, tabular data, etc. Don't worry if you don't know what are these libraries. Just think of them as already defined code so that you don't have to repeatedly write the code for performing certain functions. So these are very popular libraries in Python, which you will be extensively using as you enter into machine learning. The next thing is, where exactly are you going to write this code? Are you going to write it locally on your computer somewhere, or are you going to go to some website and run this, or do you have to install some special software? These are some questions that you may have. So there is something called Integrated Development Environment, IDE. And these are some famous examples of IDEs in which you can run Python. Spider is very famous, Atom, Jupyter Notebook, Visual Studio Code. All of these are very famous. There is something called Python Shell or REPL, Read, Evaluate, Print Loop. So all of these are places where you can run Python code. Now, a question that naturally might have occurred to you is, so what about Google Colab? Is that also not an IDE? Because in Google Colab also you can run Python code, right? So how is that? How is Google Colab not included in that list? And from this list, my assumption is that maybe Jupyter Notebook is the most popular among all of you. For me, I have used mostly either Visual Studio Code or Jupyter. I have used Atom and Spider a little bit, but not the rest of the tools. So, but what about Google Colab? How does Google Colab compare with Jupyter Notebook? So Google Colab is actually not technically a strict IDE. It's like you have a Python environment that is hosted on Google's own server and you have access to it. The advantage of Google Colab is that if you want GPU, graphical processing unit, for enhancing the speed of execution of some code, or TPU, you can actually get that from Google Colab. The option is already there. And there is also one thing called Google Colab Pro, using which you can get other complex GPUs. And this means that without having to rent the GPU from somewhere, or without having to have a physical GPU in your local system, you can rely on Google's cloud infrastructure to run the program in a much fast manner. However, if you are a serious Python developer, you will definitely not be using Google Colab. Google Colab is more used for quickly demonstrating or sharing. You don't have to install anything. You can simply go to Google Colab. If you have a Google account, you can easily start coding right away. You don't have to install things in your computer. It's like directly used in the browser. Whereas in Jupyter Lab, you have to install libraries. It may not be present in your computer. You have to first download Jupyter Lab. You have to install it. GPU or TPU access depends on whether you have access to those somehow online, or you have access to it physically where you are running your code. And both of these are basically free, but Google Colab Pro is not free. You have to pay for it. And one other issue that Google Colab faces is if you are running code that takes long time to execute, the running might get interrupted. So there are some issues like this, but if you are a serious machine learning engineer, you will be running in one of the IDEs which I mentioned earlier. But as a beginner, we can go ahead with Google Colab. So in this part of the course, we will be primarily using Google Colab and not Jupyter Notebook or any other IDEs. So we'll go ahead with Google Colab. So all you need to do is go to collab.research.google.com. So this is the Google Colab website, and you will have several options here to start a new notebook or to open some of the existing notebooks if you have used this before. I will be starting a new notebook. So click this, it starts a new notebook. And once a notebook is there, you have your coding environment ready. You can name this something. First Python code .ipy notebook. So this is like in Jupyter Notebook also you must have seen ipy notebook. Okay. So let us start coding by looking at data types and variables. So Python, unlike other programming languages, it does not have a character data type. Character is like a single character enclosed in single quotes, but a single character is considered still as a string in Python. So a variable name could be something like this: name equal to Alice. So here the variable name is name, but the value of the variable is Alice enclosed in double quotes. Then we can print the value of the variable is equal to, then print this variable. So this is like a string that is being printed. This is like a variable whose value will be printed. And then we copy this. The data type is equal to, then we can say it's type of name. So type is a function which displays the data type. And you will see once the output is there. So the value of the variable is Alice and the data type is string. This also applies even if you have a single character. So first let us try by putting this in single character, right? So name version 2. What happens now? So now this is also a data type of string. In normal programming languages, this is not allowed. And also single quotes with just one character means it's a char data type. But here in Python, that's also considered as a string. Okay. So here Python does not have a standalone character data type. All right. So now let us look at another data type, that is integer. So int data, we can put any name here, of course. Int data equal to 2. Then let us print the value. Okay, here Gemini itself is suggesting us what to write. Next time we can take the suggestion. So value of data type is int data and data type is this. So here it should show that value of the variable is 2. Data type is class integer int. So to run this code, I'm using Mac. So I'm pressing command plus enter, or what you can do is you can click the cell which you want to run and press this play button. It's for running that block of code. And then the next data type is floating point numbers. So float data equal to 2.0. And then let us copy this code and print float data. So instead of int data, keep it as float data. So here the value is 2.0 and class is float. What if this 0.0 was not there? then it will become integer, because here it's just an integer without any decimal point. So floating point means it can handle decimal points of multiple decimals. So these are the basic character data types. And here you also have had a look at the variables, right? Now, there is Boolean data type, which is true or false. There is list, like 1, 2, 3. There is dictionary key value pairs, like this: name, Alice, age 25. So we can create those things, right? So let us create a Boolean data equal to false. Then if we print Boolean data, here the data type is bool. It's a Boolean, true or false. These are the only two values it can take. Next is, we had mentioned it is list. So list data equal to 1, 2, 3. And here if the suggestion comes, so here what I did is Gemini showed me the suggestion and then I pressed tab. So when I pressed tab, the suggestion showed by Gemini was automatically fulfilled. And now I have the code automatically. I did not paste the code. So Gemini option is here. You can click this to see the available AI features. This is a recent feature since Gemini came out. So here I can run this. So here the data variable value is 1, 2, 3, but it's a list of numbers. So here the data type is list. And then dictionary data equal to, and here we need key value pairs, where you can have a variable associated with a string or associated with another string, number or an integer or whatever. So here I'm going to copy this part. And so let's say name is Alice, age is 25, and height is 175 centimeter. And here it is the dictionary data, and we can print that also. Oh, dictionary data. So here the dictionary has 3 key value pairs. So these things are called keys. Name is the key, age is the key, height is the key. The corresponding values are, corresponding to name, the value is Alice. Corresponding to age, the value is 25. Corresponding to height, the value is 175. Now, how do we access this? We can print the name is equal to, so what we can type is dictionary data dot, here there is a suggestion by Gemini. Let us run that. Dot, instead of, you can type dot get of name. This is one option. That will fetch the value of the key value pair corresponding to name. So the value corresponding to name is Alice. So this is one way. The other way is dictionary data of name. Both should work. So both will print Alice. If you wanted instead height data, then here instead of name put height. Here also height. This should print height. Now, what if we are interested in the data type? So there are 3 data types inside, right? Data type of name is, then here we can type dictionary data of name, type of dictionary. So let me delete all of this. Maybe I'll just print the dictionary alone. So here that of the name is string, whereas that of age is integer, and that of height is, let's say height is 175.5, then that should be float. So you see, it's dictionary because it can hold key value pairs where the values could be of different data types. One could be integer, one could be float, one could be string. So that is what is happening here. All right. So we looked at, I think, 6 data types: string, integer, floating point, Boolean, list, and the final one was dictionary data type. All right. So that is very good. Now we can move on to the next part. So here I already showed you how to print the data type by using this type function. So we are not going to redo that. Now, basic input output, printing is like output, right? You are displaying something to the user, which we already saw, print hello world. But now let us look at a thing where you can input as a user, you can input some number. So that can be done using the input function. So let's see how to do that. So to get the user input, we can write something like your name equal to input function. Input, please enter your full name and then say print hello, comma, your name. So here I'll print hello, comma, whatever name I enter. Welcome to Python. So here, let us run the code. So here it's asking print enter your full name. So I'll enter my full name. So hello Sridhar Panat, welcome to Python. This input feature is not that commonly used in Python, mostly if you are coding, because there are many, many ways to get the inputs when you're building a production level code. But this is one way to prompt the user to input something. And then here, this is output, right? So a computer is something where you can take inputs, it can take inputs and it can also show output. So if you have learned C or C++ coding back when you were in school, this is probably one of the first functions which you would have learned. Same thing here in Python. Then there are certain operators in which addition, subtraction, multiplication, all of those things are fine. Maybe I'll focus on these three operators, the floor operation, modulus, and exponential operator. So let's say number 1 equal to num1 equal to 3, num2 equal to 4. So here addition, subtraction are all simple, but here if we print num1 mod num2, this will actually print the remainder when you divide. So if you divide 3 divided by 4, you can't divide. So the entire 3 will remain. Whereas if this was 5, the remainder will be 1, right? So that is the remainder. And there is another one, it is floor. So the floor function is if you are dividing something, let's say your final answer is 2.3. Floor of 2.3 is 2. Ceiling of 2.3 is 3. So floor means you round down to the previous integer, to the immediate close integer, but less than that 2.3, which is 2. Ceiling means you round up to, if 2.3 will be rounded up to 3. So here the floor function is by double slash slash. So this should print if the here 5 divided by 4 is definitely greater than 1, but here the floor answer should be 1, exactly 1. So if I were to print division, then just single slash is enough. So actual answer is 1.25, but here the floor is 1. The other one is exponential. So exponential is number 1 raised to. So this is not how you use. You can use like this. So here it is 5 raised to 4. So 5 times 5 times 5 times 5. So 25 multiplied by 25, which will be 625. So this is exponential. So these are the basic arithmetic operators. You can have minus, you can have plus, but those are elementary. Okay, now comparison operator is fairly easy as well. It should output Boolean. So if we ask to print num1 greater than num2, then what you get is num1 greater than num2 is true, right? Whereas if we are printing num1 less than num2, this is false. So we can see what the output is here. So the first one is true. Num1 greater than num2 is true. So the Boolean true is displayed. And there are AND operators and OR operators. So OR this. So if either one of them is true, the output will be true. So this is true. But if this is AND operator, if both should be true. So if this is AND, the output should be false. You see, the output is false. And NOT operator, invalid syntax. So here, if it is not equal to this operator, then this is, let's say num1 not equal to num2. So num1 not equal to num2 is true. So the response will be true. The other option is not of num1 greater than 0. So num1 greater than 0 is true, but not of that should be false. So final output should be false. But if this not was not there, the final output will be true. So not operator is applied just before the expression. So these are some some Boolean operators, and or not. So not should be applied as shown here. So not of num1 less than 0 will be, so num1 less than 0 is false. It is actually greater than 0. So for not of false is true. So here, if we also type not of false, that should also give true. What if we type not of false? Not false should be false. See, it's false. So this is the not operator. Okay, now we can do a little bit of quick practice. So here is an exercise. We should write a code that asks the user to input two numbers. We should convert the number to integer, then print their sum, difference, product, and the result of their integer division. All right. Okay, so let us write that. Num1 equal to input, please enter the first number. Then similarly, num2 equal to please enter the second number. Then we are asked to print some details. I'll show you an issue will arise because of this. So num1, let's say we want to display sum equal to comma num1 plus num2, but here there will be an issue. So let us run this code. First number, let's say it's 3. Second number is 4. Sum is 34. It should be actually 3 plus 4, right? So the reason is, let us run the code once again. First number is 1. Second number is 1. Sum should be 2, but here it is 11. And the reason why that is happening is here two strings are just getting added. So the input is taken as a string. So just try again. So if input 1 is 5, input 2 is 7, the response result, instead of it being 12, it will be 57. Num1 plus num2. If we put multiplication here, mostly it should show some issue. So let's say 5 and 7. See, string you cannot multiply. So first the string you have to convert it into integer. So here type of data, if we want to print type of num1, this will be string. If we, let's say number 1 is 4, number 2 is 2. So see, the data type is string. So this is the issue. So now let's say num1 string equal to num1 int, not string, int equal to int of num1. So you can convert to integer. Num2 integer equal to int of num2. Then here we can print sum equal to num1 plus num2, but not num1 plus num2, num1 int plus num2 int. So first number 4, second number 5, result is 9. And here this is integer. We can do float also. That should also equally work. 4, 5, 2, 5 plus 2 is 7, but converted to floating point 7.0. Okay. So in the exercise, we were also asked a few other things. Difference, product, these are fine. Integer, division, this is also fine. So if we are asked just the division, then it is just divided by. But if we are asked the floor, then it's slash. So let's say we are dividing 7 by 5. Then the result is 1.4, right? But here if we are calculating the floor, then it will be 1, because 7 by 5 means 1.4. So it will be rounded down. Okay, so that is the first exercise. Yeah, now let us look at the if else statements in Python. So now next is if else statements. So let's say temperature equal to 27 degrees Celsius. Then an example is if temperature greater than 25. Okay, it already gave me the suggestion. Gemini gave me the suggestion. I just selected it, but I want to show you elif also. So if temperature greater than 25, it is an okay day maybe. Elif temperature less than 10. So if it is greater than 25, it's hot. Less than 10, it is too cold. And else, meaning if temperature is between 10 and 25. So see, you always have to, whenever there is an if statement with the condition, there should be a colon. There should be a colon here. Else colon, print it's a normal day. Okay, so here when we run, it's a hot day because temperature is greater than 25. But if this is 23, it should print it's a normal day. Whereas if it is 8, it should print it's too cold. So based on the value here, if else, which statement is getting executed is decided. Fairly easy. I'm sure most of you know this, but just do it once just for practice. Yeah, another thing is Python just uses indentation. So instead of defining something like curly braces or something, instead of doing like this, Python simply uses this indentation. So this space is called as indentation to decide what comes under what. So here there is one indentation, so this is coming under if. That's the difference between Python and say C or C++. Loops is what you will be using the most. So let's first define a variable, list1 equal to 1 2 3. Okay, now for item for loop for item in list1. So here you are picking each item from this list1. Print the value of the item is equal to item. So now this should print the value is 1, value is 2, value is 3. What if we had 556, something like this? Then those will also get printed. So here you are iterating through each item in the list. What if you want to explicitly iterate 4 times? So for I in range of 4, then here you can say list1 of I. So here it will go from list1 of 0, list1 of 2, 1 of 3, 1 of 4. So list1 of 3 means it will print the 4th item. First item will be list1 of 0. So this thing for I in range of 4 means I will be initially 0. We can print that the value of I in this iteration is equal to I. So here I will go from 0, 1, 2, 3. Okay, 4 times. So this is the for loop. Now we can print the while loop. While let's say I less than 5. I think Gemini has already given me the perfect thing which I was about to write. But when while I is less than 5, print the value of the item is list1 of I. And here you are modifying the value I equal to I plus 1. So here let me just comment this. So for commenting, I'm selecting this and pressing command slash on Mac, command and the slash for the divided by that slash. So here when I run, it will print the value is, so it will print the first item, and value of I in this iteration is I equal to I plus 1. Accidentally rewrote it. So basically I wanted to start with I equal to 0. So what I can do is denote that start and the starting I equal to 0. So now if it is I equal to 0, so list of 0 up to list of 4 will be displayed. And so while loop basically runs till this condition becomes false, right? So if there is no modifier here, it will cause an error because this while loop will keep on running and your computer will run out of memory. If this was 3 in the starting, then this will only display I of 3, list 1 of 3, list 1 of 4, list 1 of 5 does not exist. So here it will print list 1 of 3, which is list 1 of 3 initially, and then list 1 of 4. List 1 of 5 will not go through the while loop. So 0, 1, 2, 3. So list 1 of 3 is 5, list 1 of 4 is 656. Okay, so this is while loop, and basically that's it. For I also showed this I in range of, then while loop. And now the last part of this lecture is functions. I also want to cover about classes, but I want to dedicate one full lecture for that, because classes, in my opinion, is probably the most important concepts. Classes and functions and loops, these three things. Among this, the most complexity is for classes. People struggle most to understand classes. Functions people use more often. Loops people use even more often. So for classes, I will dedicate one entire lecture. So here function is basically piece of reusable code. So if I define a function, this is how you define function. Def, let's say print name is the name of the function. And if we are passing name variable to the function, then you need colon here, then say print the name is comma name. So running this will not result in anything because you are just defining the function. Now if you call the function print name of Sridhar, it will print the name. If I pass an integer, it will print the integer, because here we are not defining whatever value we pass into this variable, the data type becomes that. So we can print that also. Print the data type here is type of name. So here if we are passing one, data type will be integer. If you are passing some name, data type will be string. So it depends on what you are calling the function with in this case. Functions can also return values. In this case, we did not return anything. So let's write a function that returns sum of two numbers. So define sum of num of a comma b. So two values are being passed. Sum equal to a plus b and return sum. So this will return sum, and here we can call print the sum of, so let's say first number is num1 equal to 5, num2 equal to 7. The sum of num1 and num2 is equal to, what we have to do is like call the function. So here sum equal to sum of num of a comma b, but instead of a comma b, we are passing num1 and num2. So here this can be anything, right? But while passing, you can pass this value. So you don't have to write here a and b. That will be invalid, because here it's a name that is assigned to whatever value is being passed here. So num2, so sum equal to sum of num1, num2, and then here we say print sum. So when we print this sum equal to a plus b, return sum. Yeah, so now sum equal to 12. One more thing we can do is, instead of storing here in the sum, we can directly call it here. So we can directly call here, then also it will be 12. So this is valid. This is also valid. Just printing the sum, because here we are calling the function here and storing the sum here. Here we are directly calling the function. So whatever is returned is being printed. Here, on the other hand, the value that was stored here is getting printed. So this is how you return the value from a function. So here you are returning sum. If you return 2 into sum, then the output will be doubled, 24. So whatever you want to return here, you can return. All right. So that is fairly simple thing about functions. Then there are global and local variables. So what we can do here is to display how variables can be residing only inside a function and sometimes only outside the function. So let's say a equal to 2. Okay. Then let's say define print function where it prints the value of some variable that is being passed. Then let's say this variable name is x. So now if we say print a, and if we call print function of, and let's say x is something like test, then what happens is this is not printing test, it is printing a, because this variable a is globally accessible. So this variable a equal to 2 is defined outside the function, but it is accessible globally. But whereas if we ask to print x, then it will print x, the value of x, that is whatever is passed test. But outside here, what if we say print function x? Sorry, not print function, print x. What if we ask to print x outside the function? This x does not exist outside the function, so this should show an error. So what we can do is, let's say we are defining something inside here, print new variable, new var equal to x. And then here we are trying to print new var inside the function. Here we are trying to print it outside the function. Here also an error will be there because this new variable is not defined. Whereas if we say that global new var, so this new variable becomes globally accessible. Now if we run the function, because we have defined it as global, it won't remain just confined within the function. So this will now work. It will print the value test, because the value of this new var variable is whatever value of x is, and value of x is whatever we are passing into the function. So this is about global variables and local variables. Okay. Okay, now there is error handling. Here, some of the common types of errors that you can encounter. So division by 0 is very common. So if you ask to print 2 by 0, this should show division by 0 error. And or if you use string 1, let's say first is my first name and second is my last name. So this will work without problem. It will combine the two strings. But what if it's multiplied by? Then this should show an error. So this is another type error. You can't multiply two strings. Previously it was division by 0 error. So I'll print that also. Print 2 by 0. So it won't even run here unless I comment this. Then it will become 0 division error. Here it is type error. What if I write something like this? Print Sridhar, but I forgot to close the bracket. Then syntax error. Here it is syntax error because I have not followed the proper syntax. So syntax error. Now if I follow it, it should be fine. Now if I run this part, print 2 by 0, it will be 0 division error because this is not allowed. So if it is 0.1, that is fine. Similarly, if I run this will show an error of type error because you can't multiply two strings, but you can add them to combine them into one single string. Then the error is disappeared. There are a few more errors which I had mentioned here: syntax error, type error. Okay, value error. We can check that also. So let's define a function. Define integer, or define test function of a, and here let's say I am passing something and print a. Then we can call here whatever we pass, it should work. So here if we pass 2, it will be printed. Now let's say here we are doing something like a equal to int a. So you are converting a into an integer and you are storing it within a itself. Now, if we are passing an integer, this won't be a problem. Or if we are passing something like a float with something like this also hopefully will not be a problem. But if you pass some name or something, then this should show like a value error. So you are passing here int of a is expecting something that can be directly converted to an integer by removing double quotes. But here, if you remove double quotes, this will simply be a name. It's not going to become an integer. What if it's 1.3? Then also it's a value error, because by removing double quotes, you don't get an integer. So this is the value error. All right. So that brings us to the end of this lecture. It was very elementary. And for those folks who have already having good familiarity with Python, this lecture is not meant for you. But for those who are running their first piece of code in Python, or those with very little experience in Python, I hope this at least gave you some idea of what are the different data types, what is function, how you write function, how can you return a value in function, some common errors that you might encounter, etc. In the next lecture, we will learn how to write a function that can help us multiply two different matrices. We will do that completely from scratch without using any libraries, so that we are comfortable dealing with arrays, I mean lists, lists of lists, which will be matrices, and for loops, etc. Right? So that's what we will do in the next lecture. And there is one more lecture that I'm planning. And in that lecture, I plan to purely talk only about classes in Python, which is very important as well. So we will meet again in the series for the next lecture. Until then, please take care. See you soon. Bye.